So, hello everybody and welcome to our first afternoon session in the analog basis part. Our guests today are Marsh, Fiona McAllister, Joan Bertrand from the International Space University from UK, and they will talk about multinational design of Mars missions. So I would like to ask the auditorio to switch off the cameras and the microphone, and you may start your lecture now.
Thank you, Zabina, and for the introduction. A very good morning, good afternoon, good evening, wherever you are tuning into our presentation today. Thank you for your time. My name is Marsh, and I am an aerospace engineer based here in France. And I am studying and wrapping up a master's at the International Space University in Strasbourg. Currently, I'm attached to the Japanese Aerospace Exploration Group, doing R&D work with the Environmental Control and Life Support Systems unit. I am very pleased to be joined here on this virtual stage by my friend, classmate, and colleague, Fiona McAllister, who is tuning in from the UK at the moment. Currently, she's pursuing a PhD in astrophysics at the Mullard Space Sciences Laboratory at the University College in London. And as Zabina pointed out, our friend, colleague, and classmate, Joan Bertrand, is also joining us from Metz in France, and he'll be here to help coordinate this presentation. The title of our presentation is Multinational Design of Analog Mars Missions. Next slide, please. So we're going to give you a quick run through of the presentation roadmap. We're going to begin by sharing a little bit about who we are and how this project came about, before touching on some of the background and context relating to the project and the major entities that we explored. From there, it informs a sequence of observations and shortcomings that we identified throughout the course of this project, before Fiona then takes over at the wheel and walks you through a series of our actionable recommendations before tying things off and wrapping it up with our conclusions. So, who are we? We are 5 master students at the International Space University in Strasbourg. And typically, annually, there is an astrobiology elective. And as part of the elective, students are asked to select points of interest that they'd like to study and uncover. And for us, we all selected analogs, and that is how we came together as a group. And we realized when we were grouped together that we had a common interest in Martian analogs, and we've sort of stuck to that ever since. And as part of the astrobiology elective and the assignment, we were tasked with identifying a number of different entities who utilize existing analog sites, or indeed create their own, to fulfill their own specific targeted goals. Now, considerations for us had to include aspects like space goals, capabilities, geology, space operations, philosophy, etc. And we know that different space agencies have differing goals and different needs. And so, on balance, we considered the following entities: the United States of America and NASA, the European Space Agency, which includes Canada, the Russian Space Group, Roscosmos, China and the CNSA group, and India's ISRO, the Indian Space Agency. Next slide, please. So, what do we know? We know that the Artemis program is going to be launched and set forth in a few short years. And upon successful completion of that, Mars is perceived by many as the next great step in space exploration. And all the different agencies appear to go about researching Mars and aspects of Mars missions in very different ways, and the goals are evolving with respect to a mission to Mars. We know that analogs are used to mimic Mars mission characteristics, and space agencies use them as platforms to conduct research. These are the 5 space agencies that we considered in this project. We kicked things off with NASA, who consider many different aspects relating to a Mars mission: crew safety, psychology, physiology, habitats, life sciences, operations, technology, and geology. And there are numerous analogs that they use, and many of us here may be familiar with them already. The Hawaiian-based exploration analog, High Seas, for instance, which is used for exploring aspects of psychology in crew. Let's say boredom of food or menu fatigue, as some of us are familiar with, or looking at geology at craters in the US, for instance, in the Mojave Desert or in Meteor Crater in Arizona. The European Space Agency has a number of similar research objectives. Psychology and physiology are also explored. Antarctica's Concordia Station plays a prominent role, particularly with respect to psychological aspects of a long-duration Mars mission. The life sciences, geology, and ops and tech, once again. Roscosmos currently don't prioritize human exploration to Mars as a very high priority, but they have collaborated and hosted missions in the past with other space agencies. For instance, ESA. The Mars 500 ground simulation is a good example of this. It ended in 2013, and they were looking at psychological aspects of how crews behave over a 500-day mission to Mars. And they also look at geology, ops, and technology. And we can begin to see patterns here with common objectives. Going further across, we look towards India, who are looking at aspects of Martian geology. They have their own analog sites that have identified in the Indian subcontinent, particularly in Lonar Crater in southern India, and in Ladakh, closer to the Himalayas. And they're also looking at operations and technological aspects. Finally, we're looking at the Chinese, the up-and-coming Chinese CNSA. They are looking at a few aspects, and we anticipate them to only grow in what they begin to take an interest in research, psychological aspects, habitats, geology, ops, and technology. Now, from the bigger picture, the pattern here is a number of them share common interests. Psychology, for instance, between NASA, ESA, and Roscosmos, it's an obvious one. Ops and technology is one that transcends across all the agencies, and that includes geology as well. So how does this look when it's mapped across a table and different fields of study and different host countries in the different agencies? And this table sort of encapsulates that. We see here that life sciences, for instance, different host nations and their respective agencies use different analogs to conduct research and study in life sciences. NASA, for instance, uses Lake Ellsworth in Antarctica. The EU, Canada, ESA, looks to biomex. China, the Gobi Desert. India, Ladakh. Russia, biosphere, and biomex. And as we go further down, we see that each of these agencies use different analog sites. And indeed, some of the agencies, to our knowledge, haven't had analogs allocated yet to pursue those research needs, or indeed haven't got the analogs available to conduct research. So as we go further down to the physiology, behavior, and psychology, PVP, again, similar trend. India, for instance, here doesn't have an analog that we've identified to address the research requirements relating to PVP. And geology is similar. We have yet to identify an analog that the Russians, Roscosmos, use to research Martian geological aspects in an analog here. So out of all this, what are some of the observations and shortcomings that we have observed? And to help us distill some of those shortcomings, we asked ourselves questions. And we asked ourselves many different questions. These are just some of the top level questions here in this illustration. Beginning with, why hasn't there been an interagency analog mission since Mars 500? Back in 2013, this is 7 years ago now. There was a lot of research centered around it, particularly the psychological aspects. And there was a lot of excitement about that. There was a lot of energy. And we haven't found a reason for why that hasn't resumed since. The other question that we've asked ourselves is, what is the best analog to meet proposed research requirements for a Mars mission? In other words, is there a way to quantitatively assess analogs against each other worldwide and rank them and see which one is best suited to meet the research requirements of the entity or agency that is involved? Will space agencies collaborate on future crewed Mars missions? We know that international collaboration is a huge element going forward with the ISS and the Artemis program. So is this going to continue towards Mars? We know that NASA has outlined a sequence of steps to go to Mars, but we have not seen elements where that involves external international collaborators. But if they are going to collaborate, how will space agencies prepare for an international Mars mission? You know, if we're going to collaborate on such a large scale, what are the mechanisms that we have to put in place for that to happen? And so after asking ourselves these questions, we've derived a number of observations from them. And to start off with the top left, space agency goals don't necessarily correlate. They allocate the goals based on priority, funding, and timing. We also appreciate that for future missions, if they were to collaborate, next slide, please. If they were to collaborate, there is no clear framework shared among space agencies to deliver an international mission to Mars. There also appears to be an inability to compare analogs worldwide based on research requirements, fidelity, and utility. And we think there's an opportunity here to create a systematic approach for that. And Fiona will address that in a few short moments. And of course, we identified that there is no evidence of a mechanism for designing and implementing a multinational analog. And all this sort of webs together and informs what happens next in our sequence of recommendations. Fiona, over to you.
Thank you. Sorry, I'm just going to request control of the slides. Thank you very much. So yeah, first of all, thanks Marco for giving us a nice contextual background into the work that we've done. So what we've actually done with these shortcomings, we've identified a series of recommendations to try and help tackle these problems. So I'll go into a little bit of detail into what each of these are as we go on, but just for now, you can consider the recommendations as follows. So first of all, we need to identify a neutral custodian to broker deals and agreements for these multinational analogs, the creation of an analog calculator which would compare different analog sites, and using existing previous analog sites, private ones. And also we want to encourage the creation of an international pool of resources for the creation of new Mars analogs. Involving a neutral broker in particular is going to be very vital in enacting these agreements and also to establish this pool that we've been talking about. So for this, we initially looked at governing bodies that could act as brokers or custodians for an international agreement, such as UNUSA. Now, UNUSA, of course, is a branch of the UN, which is concerned specifically with the promotion of peaceful uses of outer space for space affairs. But they also provide a means for space agencies to communicate with each other over mutual goals. And also, and these include using space technology or space platforms for Earth and even humanitarian efforts, so not just science and technology. However, in our research, we actually found a more appropriate choice than UNUSA for our goals, the International Space Exploration Coordination Group, which I'll refer to as the ISECG from here on. So the ISECG is a forum that's composed of 24 international space agencies, including the 5 that we've mentioned earlier. And actually, at the time of this research, it was only composed of 22. Within the last few months, this has expanded with the addition of Brazil and Thailand, showing that this forum is continuing to grow and continuing to expand and become relevant. Unlike UNUSA, they are not a governing body, but are built upon a framework of coordination between multinational partners and a shared vision for the future of humankind. And this is exactly the type of forum that we need to discuss the future of multinational analogs and where they could and should take place. So, and at the time of our research, this was only the beginning of the conversation. As of September this year, the ISECG has announced further international collaboration for Moon and Mars exploration efforts. And as part of this meeting, the ISECG highlighted areas for greater collaborative efforts between international space agencies, especially in encouraging new space emerging countries to collaborate and contribute to new efforts. So ideally, the ISECG would provide a means for these agencies to communicate, collaborate, and ultimately create new Mars analog missions. So the recommendations that we have created as part of our work can be considered as recommendations that we are giving to the ISECG to help foster an environment for Mars analog talks. So as part of our recommendations, we included something called an analog calculator. This might seem a bit weird because that's because it just doesn't exist yet. So this is an emerging idea that actually we can credit to Marco, and it's based off of the need of a quantitative way to compare and create new analogs based off of different fields of interest, such as life sciences, geology, technology. And this idea is actually informed by a report that was produced by NASA in 2011, and it outlines the need for an analog assessment tool. So part of the key takeaways from this document is the need for an understanding of the fidelity of different analogs, which basically means how true they are to the Martian environment, and a means to rank those analogs. And in fact, this document actually suggests a mathematical model to do so, which implies that this is then easily computable and actually possible to make an application. And we would call this application a calculator. But more than that, this analog calculator should actually be able to create new analogs based off of these requirements and taking into account, for example, potential geographical locations of high Martian fidelity. But how would we find that information? And believe it or not, we actually do have some of that information already. These are two documents provided by the Lunar Planetary Institute, which contains several prospective sites for analogs and includes scientific proposals to actually verify the validity of these sites. For the most part, these proposals are largely based off of geological considerations and similarities to Mars. So these analogs are primarily interested in the understanding of the formation of certain structures in Mars, how rovers might, for example, interact with Martian terrain, and also the possibility of the development of life on Mars by comparing extremophiles on Earth to similar Martian environments. So these papers already provide key information about viable new sites for a variety of future analogs. However, these documents are becoming a little bit outdated. They are nearly 10 years old, and within the time of our research, which is only the last few months, we weren't able to find newer documents than the ones that we show here. Although there may be some, they're just not readily available. With what we've discussed earlier, it's also important to note where these potential sites are, as some of these territories might be difficult to access, for example, due to diplomatic reasons. Despite that, there are still very many strong examples in these documents, and we identified a handful ourselves as examples that we can show as good candidates. Now, in an ideal world where our calculator exists, an algorithm will do this instead. However, for now, we're just going to show you an example of neutral sites that we have picked as a group for the creation of new Martian analogs. Now, the great thing about the sites that we picked, and here's a selection of them here, is that the fidelity is backed by interested scientists who contributed to the proposals. And also these sites are all across the world in a variety of different continents, ensuring that they are accessible for multiple countries. They're also in territories that are research institute owned or private primarily, which involves reduced diplomatic issues. But also, in other words, these areas, they're all rentable, and they would also contribute to the scientific institutions hosting those areas, or even the preservation and maintenance of these sites. Some of these sites, for example, like the site in the Andes, it spans multiple countries, so no one government has single claim to them. Now, as I've said, this is by no means a comprehensive list. There are almost several hundred examples in the documents, but here as a team, we picked just these few just to illustrate a point and to show that this is a valid means moving forward, and that development of new analog sites is definitely possible. However, as we all know, creating new sites is incredibly expensive. So fortunately, there are pre-existing private analogs that we can make use of instead. As a global collective, we have a responsibility as a species to become more mindful of reusing what's available and to improve our environmental footprint. Some of these sites, for example, have already been used as Martian or lunar analogs in the past, and they can be adapted for new use and missions in the future. The other great thing about reusing what already exists is that it lowers the cost barrier, as new facilities don't need to be built, or rather perhaps fewer facilities will need to be built. A lot of these sites you see here are actually privately owned. So, and they can also be privately rented. For example, High Seas, which is in Hawaii, is privately owned, and NASA have used it several times, and it can continue to be used in the future. Although we also suggest that space agencies themselves rent out their own analogs. For example, Roscosmos, which has a dedicated analog site, which could also be reused. And this finally brings us to the big question. How do we fund all of this? Creating new missions costs a lot of money, and reusing old sites, while it is cheaper, it is still a significant cost nonetheless. So our answer is basically that agencies will need to collaborate with one another to distribute risk and cost so higher fidelity analogs can be made in the future. And this would all hopefully be done through the ISECG as a broker. We suggest the creation of a funding pool from both governments and research institutions, since many of these analogs will contribute to greater scientific interests, so we might be able to attract more funding from outside of space agencies. A committee, likely informed by the ISECG, will also need to be formed in order to manage the creation and distribution of future Mars analogs. And last, but certainly not least, we need to create some sort of policy or rules. This is to ensure that analogs conform to an agreed upon understanding between the host or the research entity hosting the analog and those carrying out the research. So to conclude, for the future success of Mars missions, we need more multinational Mars analog missions. However, we have identified shortcomings that are creating roadblocks in preventing this from happening. The biggest hurdles, as are always the case, are diplomatic relations and cost. And while we can't eliminate this entirely, it can be mitigated through a body such as the ISECG. So we proposed a list of our own recommendations, ideally that can be proposed to the ISECG to help space agencies going forward and to help them develop these missions. And just to show the viability of our research, we even showed a short list of possible future sites, but mostly as a means to show that this is a valid area to explore and also to contextualize the need for our analog calculator, which would automate and improve this process. And that wraps up our presentation. So thank you very much for listening. We would also like to thank our professor, Dr. Hugh Hill, for running our wonderful astrobiology elective and giving us the opportunity to write this work. We'd also like to thank our external consultants, Sarah Halpin and Brian Ramos, who provided a lot of useful insight about analogs and having experienced them firsthand themselves. And finally, special thanks to Eileen Chong-Castro, who helped design the wonderful graphics in this presentation. And absolutely last but not least, thank you to the Mars Society for giving us this platform and for hosting us today. We are eternally grateful. Thank you very much. And please, if you have any questions, feel free to reach out to us on any of these emails. Thank you very much.
Awesome. Thank you guys so much for joining us. We're going to go ahead and start with the Q&A portion. It doesn't look like we have any questions right now. I think there might have been an issue with the Zoom link, but this is going to be recorded, so we can just go ahead and keep discussing, or if you guys have anything more to add. I did want to ask a couple questions. So you said the analog calculator would take into account things like cost and
Yes.
size and things like that. Did that sort of system show any favor towards private analog missions or any of the more multinational analog missions, or generally multi-agency or publicly owned agency analogs?
Shall I take this one? You can chime in after.
Yeah.
I think it's really about all-encompassing analogs, Danielle. We want to incorporate as many analogs as possible in this systematic evaluation, and I think the more informed this assessment is, the better decisions can be made. And that really is what it's about. Who can bring what to the table? How much can they bring? Where are they going to do it? And who's going to decide how it's done? And the calculator is centerpiece in a lot of this from a quantitative aspect. Isn't that right, Fiona?
Yeah. So, I mean, first of all, I want to point out that sadly, this calculator doesn't exist yet. And it's very largely informed from this NASA analog assessment tools PDF, which is easily available online. But it contains an equation. It's very basic. So in order to make this a reality, you'd have to alter this equation more. But it's very similar to like a weighted loss function. So you can consider fidelity, for example, as the primary characteristic that's influencing these weights from what I can gather from this model, but it doesn't so far, cost would of course affect it, but the thing that we're going to find is that private analogs, because they're rentable, you don't have to create a new place. They will ultimately, or they should ultimately be cheaper. So I think you'll find, at least initially, that it will favor the renting of old analogs, but if you need something specific, you'd need to create something new. And in which case, that's, I think, where the analog would be more useful, the calculator would be more useful for generating new data and giving a cost estimate for that. I hope that helps a bit more.
Yeah, it does. Thank you. Also, I know you were talking about funding as an issue in terms of privately owned companies or people investing in these analog missions. Speaking as someone from university and you two as graduate students, do you anticipate any university collaboration or funding in that sense?
Well, Fiona, maybe I can chime in once more on this one. I'm working with a university group
Yeah,
in Lausanne in Switzerland. They're running an analog project designed and tailored for students by students called Asclepios. And, you know, I think going forward, I would recommend looking them up, Asclepios. And I do think going forward, there's going to be more and more of this. And I think this is a big part of education. And there's a lot of really exciting initiatives that drives projects like that. And many elements of analogs are included in the education, whether it's payload design, whether it's psychological aspects, whether it's interior design, lighting. Many different mission characteristics get considered, and I think that all brings value in, you know, creating a system or an analog in the future that we can use to develop multinationally or privately to send crews to Mars. I mean, and I think this is the foundation to that. Fiona?
Yeah, basically the same thing. I contacted Asclepios as well. They were really lovely. They're run by a multiple Swiss institutes. So they do have some government funding, but they're also, yeah, they're primarily university run. It's all done by a team of students. It's really impressive to see. And I don't know how much I can reveal because I'm pretty sure this was shared in confidence, but it was a relatively affordable scheme. So of course it's funded with help from the government, but ultimately, as with any of these sort of with space things, you need to frame it in a way that the public will understand and will help improve just general medicine like on Earth. So one of the great things about pretty much any analog, especially when you're involving human beings, you can analyze health effects and isolation, which is useful regardless of the context. It's just trying to, again, frame that. And I think once other institutions start to recognize that value, we might see more Mars analogs. I mean, the table that we showed in our work of just some of the analogs that are rentable, there, I think some of those, there's particularly one, I think D. Linares actually gets quite a lot of interest, and I don't know how much of that is private and how much of that is government, because I can't recall exactly, but I know there's at least one of these sites has a lot of interest from the Israeli government, I think. So yeah.
Awesome. I know we were also looking at the chart where it was showing the multiple fields of study and how different space agencies would allocate different analog stations to each one. Would you say there's any benefit to the places that had multiple different fields of study conducting their studies in one analog station?
Fiona, do you want to start this one?
Yeah. Well, I think it's the issue with analogs, or well, not analogs, but with missions in general, is you can't really isolate any one specific effect, right? You know, when we see this with the ISS, you can't say that that any cause is due to microgravity versus radiation versus isolation, so on and so forth. And I think analogs in a way are the same. So with these really large scale experiments where you're doing multiple things, it's more true to the simulation because you've got multiple things going on that you in a way can't control, but it's poorer in terms of actual experiment quality because again, there's less things for you to control. Like there's more things which can be difficult. So in terms of validity of the simulation, I think there's an edge there because there's more going on. I think NASA is probably the best example of this because they usually have lots of things happening rather than just analyzing one specific thing. But this is also particularly relevant for crewed analogs. When you're looking at analogs for, especially for like terrain and operations, those tend to be a lot more specific and a lot more localized. And because of that, we've got, again, very impressive rovers that hopefully when they get to Mars or the moon will be able to be much more sophisticated than what we have in the past. And part of that is the specificity. So honestly, I think it just depends on what you're looking for. But there's no right or wrong answer, really. I think just having an analog is a good start. So yeah, I hope that helps.
Awesome. Well, thank you guys so much for joining us. You guys have
Thank you
been
for having
really
us.
excellent presenters. And yeah, thank you for joining us here at the Mars Society.
Thank you, Danielle. Good to be here.
Thank you.